Yes, sir.
I'm discussing what is electric field. So electric field is nothing but space surrounding charge within which unit positive charge placed experiences force is called as electric field. Last class I explained force. Today I am doing maximum of field. Electric field. The space surrounding charge within which unit the space surrounding charge within which unit positive the space surrounding charge within which unit positive charge placed experiences force the space surrounding charge within which unit positive charge placed experiences force is called as electric field. That means if this is charge, if I place here unit charge
Hello.
means test charge, yes. So if this charge is getting repelled, that means there is field existing in the vicinity. So whenever we want electric field, it is nothing but space surrounding charge within which when you place unit positive charge, it experiences force. Hello?
Yes, sir.
Now define electric field intensity.
Hello.
Yes? Hello?
So sorry, I got disconnected. Electricity went at my place.
Tasmay na?
Yes, sir.
Don't worry, I'm recording the lecture. Even if you get disconnected, I will send the recorded lecture after later. Okay?
Okay, sir.
Yeah. The space surrounding charge within which unit positive charge placed experience force is called as electric field. Now, what is electric field intensity? Define electric field intensity. When you say intense, that means what? Strong or weak?
Strong.
Strong. So if I want to check my energy, whether it is strong or weak, then I should apply force on the neighboring one. If I apply force to the neighboring, he is not telling anything. That means my field is stronger. But he catch holds of my hand. That means both are similar. He slaps. That means his field is stronger. So whenever we want electric field intensity, we have to check force acting on the neighboring. So the force acting per unit charge is called as electric field intensity. The force acting per unit charge is called as electric field intensity. It is outward for positive charge and inward for negative charge. Yes, just write down, then I'm telling the formula. It is outward for positive charge and inward for negative charge.
Done, sir.
Okay. Yes, can I rub this now? Everybody has written?
Yes, sir.
Yes, sir.
So therefore we can see E is force upon charge in vector form. E bar is F bar upon Q. Its SI unit is Newton per coulomb or volt per meter. That we'll see later why it is coming volt per meter. So SI unit is Newton per coulomb or volt per meter. Its dimension is force is M1, L1, T minus 2 and charge is I into T. So A1, T1. Therefore it is M1, L1, T minus 3, A minus 1 is the intensity. Write formula and copy till dimension part. Yes, can I clear? Aryan?
Yes, sir.
अनिकेत हो गया ना तस्मै अनिकेत आर्यन?
Yes, sir.
Yes, sir.
Okay. Derive expression for intensity due to point charge Q at distance R. Point charge Q at distance R. Let charge Q and capital Q be situated in air at distance R. So force of repulsion between them F equals to K product of charge upon square of distance, which is directed outward like this. So intensity due to charge small q is force acting on capital Q. Force acting on capital Q is kq, q upon r square divided by q. So intensity is kq upon r square, which is 1 upon 4 pi epsilon naught q by r square. So expression due to point charge q at a distance r is 1 upon 4 pi epsilon q by r square. Right now?
Sir, done.
Done, no?
So 1 minute.
Okay.
Yes, sir. Done.
There are two positive charge, two negative charge, one positive and one negative. If this charge is both positive, both negative, one positive, one negative, I want where intensity will be zero. Wherever direction is opposite, intensity will be zero. So here somewhere at point P, I'm just checking direction. For positive charge, intensity is outward. For this positive charge also outward. So if two charges are positive, intensity will be zero at any point in between two charges. In between two charges, because direction we are getting opposite. Now, if it is negative, then let us see. For this negative charge, intensity E1 will be inward, that means towards that charge. And for Q2, again it will be like this. So again I'm getting E1, E2 are in opposite direction. So can I say also, when both charges are negative, intensity will be zero at any point between two charges. Now third case, if one positive, one negative. If I consider anywhere in between, positive charge is outward, negative charge inward, can the intensity be zero?
No.
No, because direction is same, na? So here if it is not zero, एक minute. Hello? हाँ बोलिए मैडम. नहीं मुझे इंटरेस्ट नहीं. So E1, E2, both are in same, so result cannot be zero. If here it is not zero, anywhere in between, let us check outside whether it can be zero. If this is Q1 positive and this is Q2 negative, if I consider point P here, then for positive charge, E will be directed outward, for negative charge inward. Can it be zero here, outside?
Yes.
Yes, sir.
Possibility is there because both are in opposite direction. If I take on right side, let us check now. Positive first charge, E1 outward. इधर भी होने का चांस है फिर तो, है ना? So I got conclusion. If two charges are like, both positive, both negative, intensity will be zero somewhere in between. But one positive, one negative, then intensity cannot be zero in between. It can be either left side or right side. I hope you follow. Hello?
Yes, sir.
तो दोनों
Yes, sir.
सिमिलर चार्ज है तो बीच में मिलेगा, डिसिमिलर है तो बीच में नहीं मिलेगा, राइट में मिलेगा नहीं तो लेफ्ट में मिलेगा. तो पहले ऐसा डायग्राम बनाओ, नीचे दो पॉइंट लिखो, फिर थर्ड के लिए भी आर चेकिंग कि राइट या लेफ्ट किधर जीरो है, बीच में तो नहीं है. ड्रॉ द डायग्राम. देखो डायरेक्शन बेस्ड चैप्टर है, डायरेक्शन समझ गया मतलब पूरा चैप्टर समझ गया. See, our November month target is electromagnetism. So you will have many extra lecture to complete this electromagnetism. When I say electromagnetism means It is electrostatic, current, magnetism, magnetic field, EMI with AC circuit. Indirectly NCERT के हिसाब से इलेक्ट्रिक फील्ड एंड फोर्स, पोटेंशियल एंड कैपेसिटेंस, करंट, मैग्नेटिक इफेक्ट, मैग्नेटिज्म, EMI, AC. 1 2 3 4 5 6 7 chapter will be my focus in November month. You don't have Diwali vacation. जरूरत नहीं ना, बाकी जगह पे वेकेशन है. Here I will take the lecture. Draw the diagram, write 2 points.
Sir, done.
Even the direction wala part properly done. And
Yes.
those 2 points, if two charges are positive, intensity will be 0 at any point between, negative then anywhere in between. All of you complete till this? Yes, completed?
Yes, sir.
Okay. चलो अनन्या रब कर दो.
Yes, sir. Yes, sir.
Ananya, law of motion, please practice again. Huh?
Yes, sir. I'll do it.
And whichever is wrong, you tell me. If you are not getting, I will explain again.
Okay, sir.
Now, if one positive, one negative, intensity will be 0, either on left hand side or on right hand side. My problem is whether it is left side or right hand side. So I know intensity is 1 upon 4 pi epsilon q by r square. This is same as for E1 and E2. If E1 becomes same as E2, then only intensity will become 0. So 1 upon 4 pi epsilon q1 upon r1 square should become 1 upon 4 pi epsilon q2 upon r2 square. That means q upon r square should become constant. That means q is proportional to r square. That means if q is more, r will be more. So from this I conclude intensity will be either left or right, but it will be close to charge of smaller magnitude. Like if this is 10 and this is minus 20. 10 and 20, which is smaller magnitude? 10. So intensity will be 0 on the smaller, closer to smaller. If this is 3, this is minus 2, intensity will be 0, close to the magnitude of smaller, whether it is positive or negative, close to the magnitude of smaller. Clear? Last point. Yeah, this wording clear?
Yes, sir.
Right. If charges are opposite, then intensity will be 0 on either left hand side or right hand side, but close to the magnitude of smaller charge. Close to the magnitude of smaller charge. Done, no?
Yes, sir.
Now you have to just tell me the direction of intensity. We are having three charges situated at vertices of equilateral triangle, equal magnitude. I want resultant intensity at P. So this is, you can take first charge, second charge, third charge. I want resultant intensity at P. Ayush, what will be direction of intensity due to first charge at B? Outward or inward?
Sir, outward.
Outward, correct. Positive means outward. So from B, it will be outward along the line. This is E due to first charge, okay? Similarly, what will be, yes, for third charge, intensity on B, outward or inward?
Sir, which one?
For this third charge, what will be intensity ka direction on B? Again outward.
Yes, sir. Outward.
This angle is 60 degree because I told equilateral triangle. So this will be also 60. Now Aryan, will the intensity even E2 same or different?
Sir, same.
Same
And
in
resultant will be 30 degrees from any of the intensity.
beta. But its magnitude, can I say it is root 2 times E?
Yes, sir.
When two vectors are equal, inclined by 60,
60
result
degrees.
is root
Yes,
3
sir.
times.
Root 3 times E.
And direction, what you said is at the bisector, this will be the direction. So just
Yes.
draw this diagram and write this formula. Same thing you will get even in gravitation. Right, draw this diagram, write this formula. Jennifer, you have completed first diagram?
Yes, sir.
So next one, I have shown three charges equal in magnitude Q, Q, Q. At vertices, I want resultant intensity at centroid. Can you tell the answer? What will be intensity at centroid? Aniket?
Zero.
Zero, correct. Because force 0 we proved. Force 0, then intensity 0 because intensity is force upon charge. Even
Yes, sir.
individually,
Yes,
if I
sir.
do individually, then this is E1, this is E2, this is E3 on the line joining, E3. E2, E3 are equal in magnitude. So it will be same as resultant E, all are EE in magnitude. So this upward E, which is result of E2, E3 and downward. So at centroid, you can say E is 0. E resultant is 0. All of you have followed why it is 0?
Yes, sir.
Okay.
Yes, sir.
Draw the two diagrams.
Yes, sir.
Sir, completed.
Yes. Now, this were for point charges intensity. Every time it can't be point charges. Sometimes it is distributed charges. So for distributed charges also I should know what is intensity. Wait for the time being here. Just wait. One more, you have to explain me direction part. A, B, C, D is a square of side A. I want resultant intensity at center of square, that means diagonal ka intersection point. I'm not interested in answer, only direction I want. Here charge is positive. What will be direction of intensity from O? Towards A or away from A? Charge is positive. Away, na? Outward, away.
Yes, sir. Towards C.
So this will be intensity due to charge at A, positive, so outward. If this is negative charge, now what will be intensity here?
Towards B.
Towards B.
Towards B. So inward means inward,
Towards.
outward means away. This is towards. E2. If E3 is positive, now where will be intensity from O? Towards OA?
Away from C.
Away from C, correct? E4 is positive. Now
Towards B.
towards B, correct. That indicates if E1, E2 are equal, E1, E3, then it will cancel each other. So resultant will come only E2 plus E4. Hello?
Yes, sir.
Yes, sir.
If E1, E3 are same in magnitude, then resultant will be E2 plus E4. Are you following this direction part?
Yes.
Yes, sir.
So just one example write down to understand the direction. Then I'm doing intensities for distributed charges. This was point charge. State board student might not have done the intensity due to distributed charges, except Gauss's application. So can I rub this now?
Yes.
Yes, sir.
Yes, sir.
Intensity due to charge distributed on thin conductor. That means if this is thin conductor, charge is distributed on its body at point P at a distance A from nearer end. We want intensity if the conductor is of length L. Just draw this diagram and then I'm deriving the formula.
Sir, done.
So suppose lambda is charge per unit length on the conductor. We want intensity at P. See, from point charge, I know intensity. At distance R, it is kq upon distance square. This is not point charge, this is distributed charge. So if I consider very small point having charge dq and distance is suppose dx at a distance x from P. So I said very small charge dq, lambda is charge upon distance. So you can say small charge upon small distance is lambda, which is called linear charge density. It is charge upon that length. So total charge, then total length. Small charge, then small length. So dq I can write it is lambda dx. Now intensity due to point charge dq. Intensity due to dq comma dE will be k dq upon distance x square. Therefore, total intensity is integration of dq from nearer end to far end. Nearer end is x equal to a and far end is x equals to a plus l. So I can say this is k dq upon x square का integration from nearer to far end. That is k constant, dq is lambda, dx from x equal to a plus l. K constant, lambda constant, integration of lambda upon x square. That x square goes up, it will become minus 1. What is integration of x raised to minus 1? Hello? See, x raised to 2 goes up, it becomes minus 2. So can I say it will be minus 1 upon minus 1 from
Yes, sir.
a plus l? Understood now?
Yes, sir.
So it is k lambda minus 1 upon x minus I am bringing outside minus k lambda 1 upon x from a to a plus l. So that will become minus k lambda 1 upon x is a plus l minus of 1 upon a. Upper limit and lower limit we have substituted. Multiply a minus inside. So k lambda minus of 1 upon a plus l plus 1 upon a. That means it becomes k lambda into 1 upon a minus 1 upon a plus l. So this is formula for electric field intensity at point P at the distance a near the conductor of length L. See, for CBSE they may ask you derivation, and for our entrance we require only formula. So if point lies on the axis of thin conductor at a distance a, then intensity is, remember, k lambda 1 upon a minus 1 upon a plus l, where lambda is charge per unit length. Please practice 2 times because this problem comes, it will be directly formula substitution. Any doubt in formula? K lambda 1 upon A minus 1 upon
No,
A
sir.
plus A. Okay, please write carefully everything. Again, I said chapter is not very difficult. So many things are there that will make it difficult. At least 10 formula we have to study for intensity. Same way nearly 5 to 7 for potential.
Done, sir.
Let others also try.
Sir,
No,
one
sir.
minute.
Sir, I did not come.
No, I am not rubbing so fast. Please do properly, no problem. We'll take more lecture, but we'll not rush.
सर
Yes.
वहाँ पे x raised to -1 क्यों लिया है वो वाला? Can you please explain that step?
1 minute, huh? 1 minute. This diagram part can I rub?
Yes, sir.
See, 1 upon x square goes up will become x raised to -2. Correct?
Yes.
Now, if x raised to n, then our integration is n plus 1. So this is -2 plus 1 upon -2 plus 1. Therefore, we got x raised to -1 upon -2. Clear?
Okay, sir. Thank you.
Okay. संतोष आपने इलेक्ट्रोस्टैटिक का शीट भेजा था मेरे को पहले. अभी जितना भी इलेक्ट्रोस्टैटिक का मटेरियल है उसका पीडीएफ भेजिए. क्या? हाँ, इलेक्ट्रोस्टैटिक का एमसीक्यू. और ठीक है, आपका हो जाएगा तो एक बार फोन करना. हेलो. Yes. So we got two formula: intensity due to point charge kq upon distance square, and this is k lambda in bracket 1 upon a minus 1 upon a plus l. Two formula we got: point charge, linear charge. Next, see, electric field intensity due to charge on semi-circular conductor at center O. So semicircular conductor at its center O, we are interested in intensity. Again, charge is distributed throughout this circumference. So if total charge is Q, total length is nothing but pi r. So lambda will become q upon pi r if we require. We are interested in intensity at point O. See, I know formula only due to small charge. So consider a small arc, very small. When we say very small means it is infinitely small, like point, having charge dq and arc length dx. Arc length dx, you can take dl because a conductor का length है. Straight line पे रहता तो I would have told x. See, every time we are using formula of point charge, so we consider very small point of length dl where charge is dq, which is subtending angle d theta here. D theta. Angle made by that dq line joining O and dq is suppose theta with right direction of x-axis. Now intensity due to small charge, which is dE, can I say it is directed outward because charge is positive? Hello?
Yes, sir.
Okay. Now if this angle is theta, means even this angle is theta. ये एक single line assume करो. तो ये theta तो ये भी theta. dE will have two component. dE sin theta and horizontal will become dE cos theta. Similarly, if you consider point here, that will also be directed outward. So it will have horizontal and vertical in the same line. Hello?
Yes, sir.
After this division or axis of symmetry, if you take point here, तो इसका exactly इसका image आएगा ना इधर, which will give you this type of field, जिसका horizontal will be on the right but vertical will be downward only. Same way, every part has its mirror image here, which will have intensity outward, right and downward. तो इधर का लेफ्ट वाला कंपोनेंट और इधर का राइट वाला हॉरिजॉन्टल कंपोनेंट विल कैंसल ईच अदर. ओनली लेफ्ट
Yes, sir.
और डाउनवर्ड वाला ना, नहीं समझा लगता है. समझा पक्का ना. इधर वाला इधर वाला इधर वाला, इसका एग्जैक्टली मिरर इमेज इधर है. तो इसका हॉरिजॉन्टल वर्टिकल, इसका हॉरिजॉन्टल वर्टिकल, वर्टिकल वाला ऐड होएगा लेकिन हॉरिजॉन्टल हॉरिजॉन्टल कैंसिल होएगा. So can I say only there will be intensity due to downward component because all x direction component will cancel each other. Any doubt in words?
No,
No,
sir.
sir.
थोड़ा ध्यान से देखो, अभी मुझे इंटीग्रेशन करना है from left to right, and then whatever answer comes that will be intensity at the center. So first part I can say, consider a semicircular ring to be charged uniformly with positive charge having linear charge density lambda. Let dq be the elemental charge on elemental length dl. dq be the elemental charge on elemental length dl such that arc subtends angle d theta at center, angle theta with horizontal x-axis. Intensity at center O is directed outward due to charge dq. It has two components, dE cos theta and dE sin theta. All the horizontal components will cancel each other due to mirror element. So resultant in electric field intensity, electric field intensity due to vertical components E equals to integral of all dE sine theta. dE means K small charge dq, its distance from center is r square into sine theta का integration. Copy till this.
Sir, done.
Okay. Can I clear it off?
One.
Yes, can I clear? Hello?
Yes, sir.
Now this is K. dq is nothing but lambda dl because lambda is charge per unit length into sine theta upon r square. See, we can't have two variable length and theta. So we have to keep the answer in theta only. What is formula for length of arc? Radius into angle, na? Length of arc, do you know it is radius into angle?
Yes, sir.
So length of arc dl, radius r, angle d theta. So I can write therefore E equals to K. Hello? Yeah. So this is K integral of lambda r d theta sine theta upon r square 1 r cancel. So now K is constant, lambda is constant, r is constant. I can bring outside. This is sine theta d theta. Left hand side, if you start from hello, left hand side, if I start from 0 and go to the extreme end on other side, it will be 180 degree. This is 0 till this, it is 180 degree.
Yes.
So
Yes.
limit of integration is 0 to pi. So I can say this is nothing but K lambda by r. Sine ka integration is minus cos theta from 0 to pi. So this is K lambda by r minus cos of pi minus of minus cos 0. That is K lambda by r minus 1. Cos 0, cos pi is minus 1, minus minus plus cos 0, 1. 1 plus 1 will become 2. So it is 2k lambda by r. Formula got it? 2k lambda by r. If it is at the center of semicircular arc.
Yes, sir.
तो तीन फॉर्मूला हो गया. एक फर्स्ट वाला ड्यू टू पॉइंट चार्ज के क्यू अपॉन आर स्क्वायर. दूसरा वाला के लैम्डा इंटू 1 अपॉन ए माइनस 1 अपॉन ए प्लस एल. नाउ 2k लैम्डा अपॉन आर. ये 3-4 बार घर पे प्रैक्टिस कर लेना बिकॉज एंट्रेंस के लिए डेरिवेशन का जरूरत नहीं. प्लीज कॉपी टिल एंड टू अंडरस्टैंड द डेरिवेशन आल्सो इफ यू आर हेल्ड अप इन एनी कॉन्सेप्ट. Tomorrow is Sunday. Can I keep evening class for you all?
Yes, sir.
What time will be convenient? Evening? Hello?
Sir, anytime.
Late रखो.
सर 12:30 को नहीं रख सकते?
नहीं, वो एक्चुअली पेरेंट्स मीटिंग है मेरा. 12:30 मतलब आप आफ्टरनून बोल रहे हो ना?
यस सर.
3 to 4:30 रख दो क्या?
Okay, sir.
Okay,
Sir, 4 o'clock.
Okay, sir.
I have appointment, sir, for doctor.
Sunday also appointment?
Yes, sir. Tomorrow.
Tomorrow is Sunday, beta.
Yes, sir. I'm talking about tomorrow.
Acha. Then we will keep late.
Sir,
6,
after
7:30
6.
to 7:30 to 9 is okay.
Yes, sir.
Yes, sir.
For others it is convenient. 7:30 to 9.
Yes, sir.
yes, sir.
ठीक है. 7:30 to 9 कल extra lecture रखता हूँ. Because ये chapter थोड़ा बड़ा है ना. And I have to teach theory also so that you understand well. Complete this much.
Sir, done.
Okay. Can I clear now?
Sir,
Yes, sir.
Tasmay?
Done, sir.
Okay. Four. Electric field intensity due to charge on half of semicircle or quarter of circle. Half of semicircle at center O. So this is half of semicircle at center O. We want what is intensity. Again, lambda is charge per unit length. Let dq be the elemental charge on elemental length such that this arc subtends very small angle d theta, making angle theta with the horizontal. Now intensity dE is directed outward. It will have two components, dE sine theta downward, dE cos theta in horizontal. So here we can say x component will be integration of dE cos theta and y component will be integration of dE sin theta. Now I don't have mirror element on the left hand side to cancel this dE cos. So my resultant will be E, which is Pythagoras theorem of Ex square plus Ey square. This also followed. X and Y are perpendicular. Result is Pythagoras theorem. Hello?
Yes, sir.
yes, sir.
So dE is nothing but K dq upon distance square, which is R, that is equals to K lambda dl upon R square. K lambda dl is nothing but R d theta. In previous one I explained you, upon R square 1 R cancel. So K lambda d theta upon R is d. Then I will get Ex Ey Pythagoras theorem. Just copy till this, then I'm clearing the screen and writing the derivation. Ex is horizontal component का integration, Ey is vertical downward dE sin का integration. then result will be Pythagoras theorem. dE ka formula in magnitude k into small charge dq upon r square, and dq is lambda dl. dl is nothing but r d theta. Yes, done till last line.
Yes.
Yes, sir.
So Ex is k lambda by r cos theta d theta. Limit of integration will be from 0 to pi by 2. So just I'm finding what is Ex, Ey, then taking Pythagoras theorem. So Ex becomes k lambda by r integration of cos theta is sin theta. Limit of integration 0 to pi by 2. So it is k lambda by r sine of pi by 2 minus sine of 0. That is k lambda by r sine 90 is 1 minus sine 0 is 0. So k lambda by r we got Ex. Ey is integration of dE, which is k lambda d theta by r into cos into sine theta Ey. So again 0 to pi by 2 is limit of integration. So k constant, lambda constant, r constant, integration of sine theta d theta from 0 to pi by 2.
माइनस के लैम्डा बाय आर.
हाँ वो अंदर रखो ना, तो अंदर वो सिंप्लीफाई हो जाएगा. Minus of cos theta from 0 to pi by 2. So that is k lambda by r minus of cos pi by 2 minus of minus cos 0. Cos 90 is 0, you know. And this is minus minus plus cos 0 is 1. So it comes k lambda by r. So we get kx, ky, ex, ey both are equal and perpendicular. So can I say resultant E will become root 2 times ex is same as ey. So when two vectors are perpendicular and equal, then it becomes root 2 times any one vector. Are you getting me what I said?
Yes, sir.
मतलब ये तो डायरेक्ट कर दिया, चलेगा ना ऐसा? root 2 times given vector.
Yes, sir.
So E resultant is equals to root 2 times any one vector. Any vector में x ले लिया. So it is root 2 times k lambda by r. So we got four formula. Single is k q by r square. Then k lambda in bracket 1 upon a minus 1 upon a plus a. K 2k lambda by r. And this we are getting root 2k lambda by r. Please copy till end now. Again see, for entrance I am not interested in derivation. So if I can memorize formula for thin conductor along the axis, for semicircle ka center, half of semicircle ka center, I am not worried about my derivation. अनिकेत ये EX का डायरेक्शन राइट में है क्या लेफ्ट में है?
लेफ्ट में.
लेफ्ट. एंड Y का डायरेक्शन डाउन और अप?
डाउन.
Down. So in vector form given, then it will be minus EX I cap minus EY J cap. If they want to make it very difficult. So this magnitude minus I cap, this magnitude minus J cap. Clear?
Yes, sir.
Okay, right.
Sir, done.
Okay. So I'm stopping here today. That PDF which I have given, please try at least 10 sums more from that.